In Module 7, we're going to be speaking about secure coding practices for session management. Session management is a little more of an obscure area than some of the others we've talked about, like input validation, but it's just as important. We're going to make sure you understand the basic concepts of session management, and you can discuss various session management techniques. We're going to show you defensive coding practices to prevent session hijacking attacks, as well as session replay, session fixation, and similar attacks. We're also going to help you prevent sessions from being vulnerable to cross-site scripting, client-side scripts, and cross-site request forgery attacks. We're going to show you how to prevent session attacks on the view state in .NET, and we're going to look at the ASP.NET Core secure session management techniques. Session management is important in web applications because web, by default, doesn't inherently maintain state. In other words, we don't have a mechanism built into HTTP as a protocol to handle keeping variable states and things of that nature. So session management is the mechanism whereby you track the entire interaction between the client and the server so it appears seamless. There are a couple of tokens that can be used in this. Session tokens are maintained through cookies, and they store information about a client, and they could be session cookies or persistent cookies, and we've already talked about persistent cookies in previous lessons and how that can be a security hazard. Of course, authentication tokens are used to authenticate users, and they can be used to authenticate the entire session, thereby you don't have to send the credentials for each and every request. The token should be uniquely recognized by the server to be part of that client. That's the first issue with session management tokens. In other words, it should not be the case that one token from one client can be mistaken for another client's token. The token should not be used by anyone else for any reason, particularly malicious uses. Any client outside the scope of the application should not use tokens in those applications. These are a few basic rules, and we're going to get into detail on how to implement all of this. There are some attacks that are specific to session management. Session hijacking, taking over an authenticated session. One way to do that is to take a user's token to gain access to their account during their session. Account hopping attack. You've authenticated with one token, and you use some manipulation to get into another user's account. That's often the case when the tokens are not well structured or not well secured. Session fixation attack. This is stealing a known fixed token of a particular user and using it to authenticate with the application and gain access as if I was that user. Token prediction. If session tokens follow some sequential pattern and I can get one, I can see what the next ones are going to be, and I can predict and then log into additional sessions that aren't mine using token prediction. Some other attacks, brute force, just discovering a valid token by trying all possible combinations. Now that's unlikely to be successful if you've done your tokens at all correctly. Cross-site request forgery, gaining access to the website by placing a malicious link or image on the target website so I can then forge the identity of that particular user. Cross-site scripting, of course, this can be done on the client side. We've discussed it previously, but in this case, it's specifically done to hijack the user's cookie, session token, or account credentials via some malicious script. Session replay. I listen to a conversation between a user and a server, and I capture the authentication token of the user. Again, if it's not secured, that's possible. Manipulating the token, or simply phishing to try to get the user's session. These are all things that are geared towards attacking session management. Now in .NET, we have a variety of session management techniques available to you, and they start in two basic categories, client-side and server-side. This is all about managing the state or the session. So the client side is just that information that's stored on the client, and the server side, of course, is that's stored on the server. And we can see here that on the client side, there are things like view state, hidden field, which is not recommended, we'll talk about that later, cookies, control state, and query strings. On the server side, we have session objects, application objects, and profile properties. So here we're looking at sample code for client-side cookie management. And you can see two different samples here. First of all, we simply have a cookie with the user ID. That's easy to manage, as you can see. The problem is that now is transmitted with each HTTP request, so it uses up some bandwidth. It also could be disabled in the client browser. Clients sometimes disable cookies. If you store sensitive data in a cookie, well, that's not a good idea. If you must do it, it must be encrypted. Hidden fields. This used to be very common. You'd have a field that simply wasn't visible. It's on your form and you stick data into it. Now, frankly, that simply should not be done anymore. It's simple to implement, but a cookie is a far better solution than a hidden field. So the recommendation is just don't use hidden fields anymore. View state. Now, this is a built-in property that's in web controls, and it's used to store and persist the data of that control. So you can turn it on or off using the enable view state property. The view state information will be sent to the server on each post back if it's sent to true. So it does slow things down a little bit. It can be set to true, or should be set to true, only if the information is used to maintain state with the server. So otherwise you'll set it to false. So it has some advantages. Very simple. It's a property and a control. You can encrypt it, and you can set it at the control level if you wish. Disadvantage, this back and forth with the server causes some overhead. What about control state? This is used to store custom control data between server trips. You can pass it to and from the server. If the view state for the control has been disabled, control state will still work. So you don't have to have view state for control state to work. Doesn't require the server resources. By default, it's stored in hidden fields on the page. It cannot be turned off like view state, so it's a reliable way of maintaining the state. It's very versatile. But the disadvantages are, first of all, it requires some programming, and secondly, it depends on hidden fields. There are tools available to hackers that will basically dissect any website they come to and pull off even hidden data. So hidden fields are a bad idea. Query strings. You pass session data to and from the server using query strings, and they're appended to the URL in clear text format. You can see an example right here on the screen. The primary advantage is this is terribly simple. The disadvantage is you can see right there in clear text what is being sent across. Anyone could manipulate it, and most browsers have some limit on URL length, so there's only so much data you can do this with. This is not one of the better options for client-side state management. What about the application object? This is used to store application state information on the server. The whole application can see it, so if you're going back and forth between different screens, they all have access to it. It's shared among multiple user sessions, and it can be used in a situation where data needs to be persisted for the entire life of the application. The data can be written in the application onStart event in your global ASAX file, or the application lock event in order to avoid any data conflicts. And you can see some code right here demonstrating this. Okay, we talked about client side, and of all those options, cookies is probably the most common. We've talked about cookie management in other modules. Make sure that unless absolutely necessary, the cookie is not persistent. Make sure any sensitive data is encrypted. But what about server-side state management? Well, there's a session object on the server side. It can store and maintain session information for a given client, and it can store information on a user basis, so different users will have different information stored, and it will persist until the user session is expired, and then the data vanishes. And here we can see a code sample where we very simply put the data into the session variable. It's not complex code, one line of code to put it in, one line of code to pull it out. By default, these session variables are stored in memory of the ASP.NET Worker process. So they can be stored in a separate process or in a SQL Server database or whatever you like. It uses the session state section of your web config file, and we can see that right here where we're setting this value. It's set to custom, in process, and it's using SQL Server. Here we're doing a slightly different option with this in the web config file. You can see again we have options like use cookies, use device profile, use URI, that sort of thing. And here we see another example, only here we're going to store it in SQL Server, so we have to have some SQL Server connection string and related properties. Continuing with other options on the session object, there are 3 different ways to maintain the session state on the web server: in process, out of process, or SQL Server. Now here on the left we can see a picture that's the in process version. And basically the session state information is stored in the memory of the web server. It's used when the application is small and perhaps hosted on a single server as opposed to a cluster. It's default, it's common, it's simple. However, if something happens to the worker process or the application domain, they get recycled, the data gets lost. And maintaining session for what they call web gardens or web farms, is not good in this methodology. The reason is this is meant to be run on a single server. If you have a ton of servers in a web farm, well then you're going to have a problem with this because your application may be distributed across more than one server. Out of process, state server mode. The information is maintained in an ASP.NET state.executable that runs as a Windows service. This mode can maintain session state in a very scalable and highly available application. So you can use it in web farms or web gardens, clusters, and clouds. Session data is persisted even if an application is recycled. The disadvantage is it's a little slower. It requires the data to be serialized and unserialized. SQL back session state. Well, this is pretty self-explanatory. The data is stored in a SQL Server database. It has the same advantages and disadvantages as the previous option we looked at because the data still has to be serialized to be put into SQL Server, so it has the same slowdown that we saw previously. What about using profile properties? That's another option. The server-side session state can be maintained using profile properties, so we allow user-specific data. The user data is not lost when the session expires because it's stored in a permanent profile. The information in the profile can be made available from anywhere in the application using an API. And you can store any type of objects. Now this has a lot of persistence. It can be used with multiple computer and multiple process configurations. However, it is slower, requires additional configuration, and data needs to be maintained as it is stored in non-volatile storage. So you're going to have to maintain this data. It will be there until you intentionally get rid of it. Let's talk about defensive coding practices. We've looked at some state management, and that goes a long way to helping you defend against broken session management, but let's look at specific coding practices now. We talked about session hijacking. Basically, you steal a valid session ID, then pretend to be that person. There are a lot of varieties of the specifics on how to accomplish this, but that's the general overview of the attack. What are some things you can do to make session hijacking really hard? First of all, encrypting the cookies. Anytime you encrypt the cookies, it's going to be very difficult for someone to manipulate them. Having them expire at a specific time, that gives that person a short window to do anything with it. We want to avoid the cookieless sessions where things are stored in parameters or things of that nature because that's even easier to mess with. Avoid specifying cookie modes to auto-detect. That means the system will automatically detect the cookie. We want it all to be manual. We don't want to use device profile for the cookies. We might want to regenerate expired session ID if you're using cookieless sessions, but we'd prefer not to use the cookieless sessions. Reset the session completely, blank it out when the user logs out or when it times out. These are just a few examples. Primarily the expiration date and encrypting the cookies are the most effective. Now, here we see vulnerable code next to secure code. What we're talking about here is the cookie in transit. Yes, we want to encrypt the cookie when we store it on the machine, but since we're using cookies, it's going to go back and forth to the server. So if we will use the require SSL, that will mean that all communication to and from the server is encrypted, including the cookie. Here we see a time limit, and it's a very simple line of code. We simply set the timeout shorter. The shortest that you can practically work with in your application setting is preferred. Here we're looking at changing things in the session state of the web config file, and again we have a timeout. We've given it limited timeout, making it harder to steal. Now here we're looking at not using cookieless sessions, and again the reason is because then the URL is used to store session identifier, and that's even easier to get at for the attacker. Simple line of code of setting cookieless to false. Avoid using the use URI cookieless session. Now a session token gets transferred, hopefully over a secure channel, SSL or TLS. If the session token is included in a URL, it's easier to find and steal. So here we see the cookieless use URI, and we see cookieless use cookies, which means essentially it's not cookieless. Auto detect mode. This is specified in the cookieless attribute. ASP.NET will determine if the browser supports cookies or not. If it supports cookies, then it uses cookies. Otherwise, it will automatically use the URL. So look at what we're doing here. We're simply saying don't use the auto detect because if that browser doesn't support cookies, it's going to go automatically to putting the session ID in the URL, which we already know is very vulnerable. So what will happen if we use the secure method here of use cookies? If their browser doesn't support cookies, they'll be given an error message. You've probably seen that message from your own browser before that says you must enable cookies to interact with this site. Very simple. If use device profile is specified in the cookieless attributes, then ASP.NET is going to look at the situation, it's going to look at the browser capabilities, see if the browser supports cookies, and if it does, then it uses cookies. If not, just like the other method, it's going to use the URL to put session identifiers. So for the same reason, we don't want to use device profile either. Enabling regenerate expired session ID. This must be set to true for always starting a new session when an expired session identifier is supplied. Put another way, the name sounds a little different. Regenerate expired session ID? Wow, that'll just restart it. No. What that means is if the session ID is expired, then you have to start a whole new session. That's why we want that to true. So if an attacker tries to use a session ID that's expired, even if it's only expired a few moments ago, the system will insist on restarting a new session and re-authenticating. That's why we always want this set to true. Resetting the session if the user logs out. As soon as they log out, we want to completely reset the session, and we've shown you a function right here that has a total of 2 lines of code. And it simply completely abandons the session using the current session abandon method, and then resets the session ID and cookies. Boom. So if the user logs out and 2 seconds later a malicious attacker tries to reuse their session ID, it will not work. Token prediction attack. You're trying to find a machine used to create a session ID and guess the next valid one. Now here we're showing one that the numbers are going sequentially from 1, 2, 3, 4 to 1, 2, 3, 5. Well, it doesn't take much for the attacker to realize the next one's going to be 1, 2, 3, 6, and just use that. Lengthy session keys to prevent guessing. Basically, the shorter something is, the easier I can guess it. This is why many smartphones have gone from 4-digit pins to 6-digit pins. If the session keys are used to track the user and maintain the session, then it needs to be unique. It's often recommended that you use globally unique identifiers, GUIDs, and make sure that these are long enough that they're not guessable. Session replay attacks. The attacker listens to the conversation, the back and forth, captures the authentication token, and sends it as if they are themselves the legitimate user. Now, in this diagram here, we can see how that would work. The attacker is eavesdropping and replaying their captured authentication token. What are some things we can do to defend against this? Well, you can see 7 defensive measures listed here on the screen. The first one, avoid storing session information on the client side. Re-authenticate the user if some critical function is being performed. So, for example, a bank account application. They've logged in, but they're going to suddenly transfer half of the account balance to an overseas account. Let's re-authenticate. Let's not let that go. An expiration time for cookies, securing the cookie transmission with SSL TLS. Do not allow multiple and concurrent authentication sessions for the same user to the application. That may mean someone has replayed. I'm logged in, you got my authentication cookie, my token, and you logged in also as me. Well, that will be 2 concurrent, multiple authenticated sessions. The system should detect that and determine that's not normal behavior. Synchronize the timestamp of the sending request with the server timestamp to disallow a request that doesn't match the timestamps. So if I send something back too much later, it won't be allowed. The server should issue pseudo-random tokens when the user first requests, and then each subsequent request, you also include that token. Using pseudo-random numbers makes it harder to predict. Okay, what about session fixation? The attacker is trying to obtain valid user sessions by tricking the user. I send the known session ID to the user and lure them to authenticate themselves with that session ID. I then use that session ID to authenticate to a particular application, allowing me to hijack your session. Several techniques can be done to execute this. If I'm going to use the session token in a URL argument or hidden form field or an unsecure cookie, then I'm vulnerable to session fixation. Here we see a diagram showing the full attack laid out in a nice graphical display. If you're not fully comfortable with this attack, you'll want to study this diagram. It walks you through 5 easy steps showing you every part of this attack. How do I secure against it? When the user logs into the application, the session data is saved into the session, creates and stores a session ID cookie in the user browser, and it remains in the user browser even though the user logged out, and that means the cookies are not deleted. Well, then I need to go back and make sure I'm deleting cookies, because the attacker may use this legitimate cookie. Session abandon, session remove all, and session clear are specific methods that will remove session data. Make sure we remove the ASP.NET session ID explicitly in the logout method or in the timeout method. A separate cookie can be created with unique ID and stored in that session. So what we're basically making sure we're doing is we're ensuring that the session identifier, whether it's in a token, a cookie, or whatever, is well secured, and it goes away as soon as the user logouts or the session expires to prevent someone else from reusing that information. And here we can see the session fixation attack using a stolen session ID cookie, and you can see the process of how that works. Here we're seeing those commands I just told you about: session clear, abandon, and remove all. And I must be frank with you, I tend to be paranoid. I tend to call all 3 methods, which is exactly what you see here. I want to make sure I've wiped out everything, because each one of them behaves slightly different. As you can see, session abandon deletes all objects in the session object, but session remove all clears all keys and values from the session state collection. That's slightly different, so I recommend just call all 3. Here we can see the secure code, where we're going through and we're adding an authentication token, and on the right you can see with the session ID we've set the value to empty, we've set the expiration to actually an earlier time, and we've completely wiped that token essentially. Cross-site scripting. Now, we've seen that before, but in this case, we're explicitly talking about attackers using it to do session attacks. And this graphic is a very nice one. It shows the user, how they're visiting a website, and how the website has been compromised to try to get at their authentication session information, so the attacker, shown here, can interject themselves in the process and take over the session. How do we prevent that? Well, we know what the attacker's doing. They're embedding malicious script. So we talked in an earlier module about input validation and preventing cross-site scripting. That's a start. We can also make sure we change the URL, rewrite the application URL for each session, expire application URLs automatically. These are things that would prevent some of the cross-site scripting using URL rewriting. Now, expiring them automatically, it has to be within a short period of time. Now, for a computer, a few minutes is a pretty short period of time. And here we can see a timestamp being used. I love when we get to show you vulnerable code side by side with secure code, particularly in this case. We're seeing that a simple change of a property, HTTP-only cookies, from false to true, helps a great deal. We prevent accessing the session cookie by setting the HTTP-only cookie to true in the web config file. It's not even a full line of code. It's one word that gets changed. Cross-site request forgery attack. This is when someone's attacking the website by forging requests from an authenticated user. They may have some malicious link or something of that nature on the target website, and the user's logged in, and so if the user clicks on that malicious link or image, a malicious request is initiated unknowingly, which was hidden in the page or image. In other words, I have been able to insert an image somewhere on a site. Now, I'm in a public part of the site. I'd really like to get at some of the authenticated stuff under the hood in that site. If I can get an authenticated user to click on my image or my link, and that link includes a request, that request is going to be sent as that authenticated user. And now I've done a cross-site request forgery attack. And that's depicted in the diagram you see on the screen. How can we defend against this? Well, don't turn on the Remember Me feature. That's an elementary one. Of course, you want users to not click on external links or images, but we can't always guarantee that. Use browser extensions that support request policy, and that provides a default deny policy for any cross-site requests. Use very specific and secured authentication tokens. Re-authenticate periodically, and that includes limiting the lifetime of cookies. Check what the HTTP refer header, HTTP origin header is, and make sure where it's coming from before you process any request. Ensure that no client access policy XML file should grant unintended access, and specifically in .NET we're concerned about the Silverlight controls because those are highly graphical and they're ones that get attacked a lot. Make sure that no cross-domain XML file will grant unintended access to Flash movies. And check whether the request headers contains an X requested with dataset. Cookie-based session management. Now, cookies are the common way things are done on the web, and I don't see that changing anytime in the immediate future, so we really want to make sure we do them securely. When you're using cookie-based session management, a web server sends a message containing the user's credential to the web browser. The web browser receives that information and writes it to a cookie. When it needs to talk to the website, it sends that same information back from the cookie to the web server to identify the user. And this goes back and forth. The cookie-based session must end when the user closes the browser or logs off the session. It's secure because all of that should be sent back and forth using SSL and TLS, and of course all the cookie security mechanisms we've already discussed. Persistent cookies are simply a bad idea. Now, you may have an occasion where you have no choice but to do them, but I would like you to really think long and hard about alternatives. The attacker always has the option of compromising sensitive data in a persistent cookie. It's stored on their hard drive. There's a lot of ways to get at it. So any information that is stored in a persistent cookie must be stored securely. It must be encrypted. But the better answer is, if at all possible, do not use persistent cookies. Now, here again, we're looking at vulnerable code versus secure code. Here, we're setting the cookie to expire for a date that's somewhat in the future. Now, that's a problem. If we don't set an expiration date at all, the cookies are only valid for the current browser session and get deleted automatically. So it's best not to even set an expiration date. Ensuring cookie security with a secure attribute. Here we have secure false, which is insecure, and secure true, which is secure. What does this mean? It simply means the cookies are only sent over a secured channel, such as HTTPS, using SSL or TLS. Using the HTTP-only attribute, client-side scripts will not be able to access the cookies if this attribute is set to true. In other words, the cookie can only be accessed by the HTTP protocol itself, not by scripts. So by simply setting this to true, you've eliminated one attack vector. View state-based session management, we mentioned briefly before. You maintain session state between the client and server. There are some security concerns since session data is passed, and it could be tampered with. There are things that can be done to attack this like anything else. And here we see a tampering attack being shown in quite a lot of detail in the graphics on the screen. Again, if you're not totally comfortable with how this attack works, I suggest you spend some time studying the screen, perhaps even pause the class for a bit, the video, and take a look at it in more detail. One-click attacks. The attacker posts some malicious HTTP form, maybe through cross-site scripting, who knows, however they get it up there, to a target that's vulnerable on some site. We send a link to the malicious form to the victim through email, perhaps. The victim is lured through some phishing technique. Click on that link. You get the remote process triggered, and the victim is asked to fill out the form, which could include confidential fields. You submit all the data, and all that data is visible to the attacker. It's a variation of phishing for your information. How do we secure it? First of all, we make sure that we're using the enable view state MAC attribute, so we're using a message authentication code to hash the view state values. We encrypt with the strongest encryption available, and we assign user-specific keys using the view state user key property. This will make the view state process far more secure if you choose to use view state. Now, hashing, particularly message authentication code, as we've already seen in previous modules, is always the way to help ensure integrity and validity of data. In other words, we have a message authentication code. If an attacker is tampering with the data, we'll discover it. And here we can see the difference between vulnerable code and secure code by simply using the view state message authentication code. Setting it to true is a much more secure way to do things. It's a very simple thing to do in the login and web config files. Securing with encryption. View state encryption mode can be set to true. It can be set to always. And what that means is it will always encrypt. Now currently, only triple DES is supported with the view state encryption mode. That may change with future versions, but for now that's the only option you have. But set it to always. The user-specific key. Now here you can see the user-specific key is a randomly generated session ID in the secure code on the right. It's just the username on the left. Well, it's a good chance I already know the username as an attacker, and if not, I can probably guess it fairly easily. That's why the code on the left is substantially less secure than the code on the right. Here we can see that user-specific key diagrammed out, and we can see how the whole process works with an attacker attempting to subvert the system and get at the user's data and authenticate as them. Secure session management practices. First of all, enabling session state. Session management in the Microsoft ASP.NET Core is handled by the session namespace. You first of all have to install that particular namespace, and you can see that right here on the screen. And then you have to add the services in the Startup CS, and that's also shown here on the screen. Configuring the HTTP request pipeline. This says the app should use session, and we again are doing this work in the startup.cs file, which is where so much of our work occurs. But you can see it's only a few lines of code. This is not overly complicated to implement. Implementing the cross-site request forgery token to mitigate those sorts of attacks. ASP.NET Core Data Protection involves some specific items to help protect against cross-site request forgery. Views are automatically protected by implementing the synchronizer token pattern. It's a unique and predictable token sent to the client, by the client to the server to identify the current user's identity. On receiving the token, if it's not matching the user identity, the server rejects the request. Now, when I say it's unique and unpredictable, I mean that it's going to be incredibly difficult for an attacker to forge this. The whole idea is if you're trying to send a request and pretend to be that user, this is a mechanism whereby the server can validate if you really are that user or not. Here we have the validate anti-forgery token filter, And you can see that's very easy to implement in code, doesn't take a great deal of code, and allows you to very quickly and easily mitigate CSRF, cross-site request forgery attacks. Mitigating these attacks in JavaScript, AJAX, and single-page applications. Store the anti-forgery token in local storage on the client and include the token as a request header, and we can see how that's done right here in code. Pretty straightforward, just ensure you have the appropriate namespaces. Many of the things we're talking about in this particular module require a particular namespace, and if you don't have that namespace, you will generate errors. Here we can see this being done in AJAX. It's not that much different than what we've seen before. The diagram here demonstrates how the process works, and on the bottom right, you can see the actual code needed. Create a result filter to generate and include the request token cookie, and configure the result filter as a global filter. A few simple lines of code done right here, and of course, the global filter is in the startup CS, as so much of our work is. Okay, let's talk about improving session security with the InWebSec Session Security Library. This is a library that can be included with ASP.NET, and it has strong binding between an authenticated user's identity, the session identifier. It ensures that authenticated user cannot use unauthenticated sessions and vice versa. If you're an unauthenticated user, you cannot take over an authenticated session. It ensures that an authenticated session ID is only valid for a specific and particular user, and it uses middleware or MVC filter attributes to be implemented. So here we have a checklist. We've talked about a lot of things. Let's look at this checklist. Ensure that you have a built-in session framework, and if possible, store session data on the server side. Employ security for that data. Make sure we have short timeouts. Make sure we invalidate the session on the server when it's over. Regenerate session IDs anytime any privilege changes. Ensure that the secure and HTTP-only attributes are turned on for cookies. Avoid using or reusing any session IDs for any other purpose. Use SSL or TLS to encrypt your communication. Regenerate session IDs if you're moving from HTTP to HTTPS. Secure any sensitive pages with authentication. Do not trust client-side state management. That is the one that's most likely to be attacked, so we want to always have server-side if possible. Don't mix session tokens and authentication tokens. If they're separate entities, they're separate. Don't mix them. So basically what we've talked about in this module is the concepts of session management, the various attacks that can be used on them, such as session hijacking, cross-site scripting, cross-site request forgery, session data tampering, and similar attacks. And we've looked at a wide range of defensive techniques to mitigate those attacks.